Okay, before the break, we were going over course policies, all of that stuff, and started looking at some various IDEs, different places we can use to write our code. Integrated development environment. It has really it's a text editor, but as we add more and more functionality, we start to change the label from text editor to something more. As tools where we can pause along the way of running the program, check check the state of the program, figure out what's going on, fix problems that way. Extra little tools to help us. But really, we're basically just running. We write a text file, some Unicode, special characters and keywords and things the computer will recognize, and then the computer knows what to do when we put them in the right order, basically. Solve problems with it. We'll talk about problem solving soon. I kind of want to jump into example and let's talk about some stuff along the way for example. So I guess first thing we need to do is install the programming language we're going to use. We're going to start with Python. So we need to make sure our computer knows about Python. And I'm pretty sure I put a link in the Ivy Learn show, but in general, we, like most things in our modern world, we just go to Google and search for it. You search for download Python. You'll see the latest version of Python, which comes out in mid-October every year. So we've just moved from 3.10 to 3.11. If you wanted to use 3.11, I haven't. It just came out last week, so I haven't updated with 3.11. Anything within the last couple of years, we'll be fine. Just hit download, and there's an installer. You'll run the installer. And then we need to set up some things. After you do that, after you run the installer, you want to make sure your computer knows about it. So you open the terminal, PowerShell or command prompt, or bash shell. What type of machines is everybody on? Everybody using Windows? I see Windows in here. I see a Mac, so it'll be you'll have the terminal there is the equivalent, a bash shell in Linux, but there's some sort of system control. Essentially the same on a Mac. You will have to change this instruction slightly, and they're working it out of the Linux kernel, but it's not out of every version of the Linux kernel yet. So on a Windows machine, if we need to get to one of our terminals, you can push Windows X, and that gets all of your Windows key, and then an X, you get all of your management and control options. Windows terminal, and yours might say PowerShell or command prompt. Windows terminal is fairly new. Some of the later versions of Windows 10 will have it, and it's on all the Windows 11. This is a really, really, really nice terminal. I have lots of tabs. I have lots of different options. It's fully configurable. We have lots and lots of control over it. We configure it with a JSON file, which by the end of the semester, we'll have a better idea about what that is. But some place where we can pass in the actual instructions the operating system knows about itself. And after you download Python and run that installer, hopefully one of those instructions is Python. You come in and type Python, and on a Mac, part of the Mac kernel, Mac OS kernel was built with, or OS X kernel, part of that was built with Python 2. So every Mac has Python 2 installed. So when you want to run the modern Python 3, make sure you type Python 3 as your instruction. On a Windows machine, you just need to type Python. You just type Python, and when you hit enter, it should change the prompt. It should tell you what version of Python you're using and switch to the little prompt with 3 little arrows there. That's how you can tell the programming language is installed. And kind of similar for all of them. To get back to our regular prompt, we type exit in with parentheses. It's a method. We'll talk about that later. I think everybody would have seen that in the SDEV 120 class. exit and then some parentheses beside it will take us back to the regular prompt. But that's the same for all of our languages, like Java. I'm teaching that class on Tuesday and Thursday, so I know it's installed. I do factory resets between every semester, so I'm often not sure what's currently installed on a machine or not, because sometimes in class I break my machines on purpose for y'all's learning benefit. Show you what happens when we do certain things that you don't want to do on your machine. It's like, oh, I know how to fix it, so I'll break it on my machine. So notice when I typed the keyword Java, one of the programming languages, it popped up some instructions, but it didn't give an error message. So the machine knows about it. Whereas if I type GNU, that's probably seen those letters before. Has to do with C++ language. That's not an instruction that it knows. So if you type in the name of the language and don't get an error message, in Python it goes to the Python terminal explicitly, or Java it pops up instructions. If you don't get an error message, that means the system knows about it. But if you do get an error message, you probably need to tell your machine how to do about that. First thing let's look at here is environment variables. How do we set up what our machine knows about? So on a Mac, there's only one person said they need to do it on a Mac. So on a Mac, you just add it to your variables there in the terminal if it didn't happen automatically. So stepping away from Windows instructions real quick, there's automatically a variable called path. And what you can do is just reassign that to say something. So if you're curious about that, Joseph, want to stick around at the end of class, I'll show you how to do that. I'm going to kind of show the Windows way now because that seemed to overwhelm. If you have a bash RC configuring your terminal, it'll be written in there, so you can also copy and paste the line from there, but I'll show you how to do that in a moment. For Windows, we have to go through menus. We have to set up what's called environment variables. So our Windows environment needs to know about, it needs some more stuff variable. It doesn't know how to find Python language per se. It worked in mine, but I'm gonna go through those steps anyway. So I'm gonna again hit Windows X to get manage those control options. And under system, there's different ways to get here. This is the way I've been going lately under system. And on the about tab, if we scroll down, you'll see advanced system settings. It's a Windows machine, so there's lots of ways to get there. You hit the start button and search for advanced Windows settings. If you go to system and about and advanced system settings, you can also get there through the control panel. When you click that, you get this little box. Probably looking at the main one here, has some different options. But under the advanced tab, there's a button that says environment variables. You click that, you'll see these two lists of variables. These are the things your computer knows about. And you'll notice the word path is a variable name on both of them. And notice one of them is for user and one of them is for system. So anything you put on the system one will trickle down to that individual user. So you usually want to go in the system path, the one they call path down here. And it's a list of all the stuff the computer knows about. All the so like here, my computer, what I can type, the instructions I can type in the terminal or command prompt, or I have mine set up so I have a bash shell running Windows as well, but that's just because bash, so I like bash. But y'all probably don't have a bash shell on your Windows system. So like PowerShell, the things it knows about is it knows about the Java programming language. It knows about itself. It knows about PowerShell. It knows about OpenSSH, so I can connect to other machines. And these are the things the computer knows about. Or down here, it knows about Python. And you notice that's way buried down deep there. You start looking through folders, it's actually in the hidden you have to turn on hidden folders. So you can't even see all the folders to get there. What I like to do, instead of trying to remember all that, the default installation place, when you install Python, you get this little default editor or IDE called idle. And it has a little terminal place to run our code. If we come up to file and new, there's a text editor place to write our code. And to remember where Python's installed or to find it, what I like to do is come here, and whenever you go to file and save, the default location is going to try to save it where Python's installed, which that's not where we want to save our programs, right? That's where the language is installed, but that is a quick, easy way to get to that. So if you type Python in your terminal on Mac or Linux, make sure you type Python 3, put that 3 there. You can do multiple versions. And it's not on the path. If you go to where idle tries to save by default and just come up there and grab that from the address bar, highlight all that and copy that, then all you have to do is paste that into the environment variables. Like paste that into one of those spots. And then that, now the operating system itself knows where to look for Python. That's environment variables. A software thing, not a Python thing. You'll notice that I also have Java on there, OpenSSH, MySQL. I guess kind of the basics there. Sometimes these get really, really long. Maybe it hasn't been that long since I did a factory reset. But all of the programming languages you want your computer to know about need to go into environment variables. And yeah, so not just Python. Anytime you install a programming language, make sure the computer knows about it. Let's go over those steps one more time. I'll cancel out of this. This time was already set up. So what you do is whatever language you're in, whether it's Python, Java, C#, you'll know you'll have some keywords that you can call up there as well. But for us, for like Python, we type that in, and we don't get an error message. When we go to our operating system control, it knows about Python. But if it doesn't, that means environment variables. So what I like to do is push Windows X to get to all of our control options. And under system, you can scroll down and find advanced system settings. But it's a Windows machine. There's lots of ways to get there, how we get through it. And under the advanced tab is environment variables. And the variable called path is all of the path is all of the programming languages that your operating system knows about. So just make sure the file path to a particular operating system like Python is included on that list. And that applies to basically all of our programming languages. And you just need to know where it's installed. Let's look at that installation. So yeah, what I always do is I open that default idle, and this works on every system. I do this on the Chromebook, on MacBook, on Windows machine, all the virtual machines I have running, as well as those. On the Quest, anytime I'm running to write code, if there's Python installed, I open idle and look at and just grab the address from there. I used to do that on a Windows machine. I have it memorized. I've seen that many times. So I have it memorized now. But that's a good place to grab that if you're not sure where it's at. Let's take a look at what the language is. Yes.
Yeah, when I did that, I got the error message that says I don't know if we found.
Okay, so did you get it? Oh, it's there. So notice you started in the prompt, looks like that. Yeah, so yours is installed. So you're actually in the Python engine. It looks like that switched over entirely to the Python engine. So type exit and then put parentheses. It'll either go back to the command prompt or close altogether. But as long as the system knows about it. But what is a programming language? So that plays, the reason I showed you how to copy that from idle is where that's installed is by default, at least on a Windows machine, it's going to be under users, and then the user account, and then app data, which is a hidden folder, so if you can't see that, you might have to come up here and click on show the hidden items. And app data and local and programs, there's Python 3.10. So here's the Python interpreter. But what we think of as the language is a little bit different than what the computer thinks of as the language. So here, right up here is a folder called lib, short for library. If we go in here, there's a bunch more folders, but if I scroll down, you can see there's just a whole bunch of Python scripts. I can go ahead and open some of these. Open this with, I'll open it with my text editor. There it is. And you'll notice that it's just some Python code. Import some module, this variable is assigned to this value. This variable gets assigned this value. It's just a file of Python code. And we create a class, we'll see those before long, some object-oriented stuff, but set up some functions and assign these, this data field or variable gets assigned this number. We'll talk about the different discrepancy and terminology there and stuff. We're gonna notice this file is just a bunch of Python code, like we would write. And that's what all of these are. ABC, that's a good one to look at. Open ABC with a text editor. It's a bunch of Unicode, some comments, and then this function name, which is followed by a bunch of other comments, and then some more Python code, lots and lots of comments, but Python code like we would write. So this is what we think about when we talk about a language. It's this pre-built stuff that we can use. There's another one here under K, keyword. Here's the big one. Open this. So here is a list of words. And these are the keywords that the Python interpreter knows. So the Python interpreter just knows this very short list of words. And then a couple of symbols, like our math symbols, plus, minus, multiply, knows what to do when it sees a colon, parentheses, so a few special characters, and this very short list of words. Sorry, what was that? Somebody asked a question? Oh. I thought I heard something, but I couldn't quite tell. So we have this short list of words, and that's what the Python interpreter knows. So we can take that short list of words and special symbols, and this is programming languages in general. We're just looking at the Python one. It's a short list of words and a few special characters, and we can make more complicated instructions. We can make more special words that the machine knows what to do with. So we start with this and then build up other more complicated scripts. And what we think of as a language, not just Python, all our languages in general, are going to be large collections of these. Pickle, we'll see that one here in a couple weeks. Open that with Sublime. So we take that short list, and then somebody built a bunch of things. So they imported some different libraries already, set up some exception handling, did various assignments, wrote some classes and methods, and looks like a whole bunch of assignments in this one. But they wrote some Python code that they thought we would need. So now we can use it. And that's what we think of as a language, is those pre-built things. All of our programming languages are like that as well. Kind of a bunch of stuff written in Unicode we can use to start writing our own stuff. Which we can go ahead and start writing our own stuff now. Let's see. One of the first assignments, that seems like a good place to start. This is day one, this is really the policy day. One of your first assignments involves that. So the discussion board for module 1, if I pull that back up here, it's not to write a paragraph about yourself. Discussion board for module 1 is write a program that introduces yourself to your class, to the class. This one, so our thumbnail is the one that has the machine Charles Babbage built, a computer with gears, many hundreds of thousands of gears. It took a bunch of people 40 years to stack up. There's so many gears in it in order to do calculations, but a precursor to modern computers. We'll talk about history and get into more formal things on Wednesday. Today's just kind of starting out. But in module 1, so we can go ahead and do some stuff. One of our assignments here should be a discussion board. Did I not add it to module 1? Oh, there it is. And well, there's kind of an example in the picture there. So instead of writing a paragraph, you're going to write a program that outputs simple sentences that introduces yourself to your classmates. It doesn't necessarily need to take any input or anything. And let's look at that for our first example and then wrap up where there's still like an hour of time to kind of do stuff and get things set up and get ready for Wednesday, when we'll dive in a little more seriously. The main thing for today was just the syllabus and course policies, and we already did that. So we need someplace to edit text. Using a basic text editor here to start with. I'm using the Sublime text editor. There are lots and lots of them out there. Any system is going to come with a default text editor, but you probably want something a step above that that'll like change colors, add some predictive text. The term for that is lexing, from the lexicon of the language, the structure, lexicon meaning structure of language. All that color changing and predictive text and stuff is called lexing, based off lexicon, which is something as programmers, we have control over. So when we do that at some point, before the computer can change colors and stuff for us, it needs to know what language it's typing in. So a good first step is to go ahead and save the file. I'll hit save, documents, delete. This is I'll call it intro, and then to tell the computer that it's a Python script, I'll give it the extension .py. The name, the part before the dot, is for humans, and then the extension is just for the computer. That just tells the computer this is a Python file. We can leave off the extension. We could give it a completely different extension and then override it and tell the computer to run it like it's Python code, and as long as there's Python code there, it'll run. But it can be helpful to go ahead and stick with the one the computer recognizes, especially in a class setting. So intro.py, that sounds like a good name. And then we just put together the text of those keywords, our predefined, more complex combinations of those keywords to build up our stuff. We'll get into this in a lot more detail. Y'all might remember from SDEV 120, the idea of variables. The computer has a big chunk of RAM, which introducing things tonight. So I'm going to introduce a picture. I'm going to draw a lot in this class, and that's something called a stack heap diagram. to explain what's going on. Everybody's probably familiar with the word database. Databases are storage long-term. When we're programming, our programs run in memory over in short-term storage. So the roughly the equivalent of a database for RAM is what's known as data structures. There's quite a few different ones, but a couple common ones are like a stack and a heap. A heap's like it sounds, they're like it sounds. A heap is just like a giant pile, which for a human sounds like a mess, but it's highly, highly organized. It's one of the best ones for a computer, but it takes a lot more work for a human. But in general, this is how the computer's internal working is going. To get more detail, I'm just going to use a heap for the picture, but computers usually has a hash balanced heap, a whole bunch of things, but there's two parts, and a stack is another common data structure. It's like a stack of plates. Right after we eat dinner, we wash dishes, and go put the plates away, and the last plate that we washed ends up on top of the stack. So when it comes around time for the next meal, we grab the first one we grab is the last plate to get washed. Does that make sense? We stack it up, and then the last one thing put on that stack is the first one to get pulled off. So a stack is a last in, first out structure. That will be very important because this is what a computer wants to do naturally. This we can force a computer into, and it will do it faster, but it takes a lot of work for a human to force it in there. So a stack, the last in, first out, like a stack of plates, is what a computer wants to do with naturally. When we write instructions, the computer reads them. Like we write instruction 1 at the top, and 2, 3, 4. The computer actually grabs that text file, reads those in backwards, so it stacks up. So like our line 30s, the last line, maybe that's read in first, then 29, and it stacks them all up. And then line 1 is the very last one read in. So once all those are read into memory, ready to be run, the computer just pulls them all off the stack. Our term is going to be pops them off the stack. So that's an important structure. We'll use that a lot. And these diagrams are going to look something like this. So in one of our instructions, we might have a variable. Since I'm writing on the board, not typing, I'm just going to write X. Typing is easy to do long, meaningful words, but that's kind of hard on the board. And then over in RAM, there's a bunch of bits reserved for that data. The computer sets up a bunch of bits, and the computer's going to recognize it because this is the computer's home neighborhood. It knows that. But the computer knows it as a number, so maybe the computer knows that that data is stored at bit 84,327. And is what I draw there. 1, 2, 3, 4, 5, 6, 7, 8. 8 little boxes, so like 1 byte. So the computer knows that it starts at bit 84,327, and there's 8 bits of data there. But a human will never remember that. Probably already forgot. I wrote it down and I forgot because it's behind me on the board. I'm not looking at the numbers. I already forgot what it is. We'll never remember that. So we need something better to call it. So maybe instead of X, well, I'll just call it X on the board. Whatever we want to call it, we can give it a meaningful name. We'll call it X and just tell the computer that X means the same thing as that. So we're just giving a name to a location in memory. That's what a variable is. Think about your neighborhood. If you're giving instructions or directions to your neighbors, you would tell them very differently than you would to somebody from out of town. Talking to your neighbors, you can say things like the Jones house, the place that used to have green shutters, and your neighbors know exactly what you're talking about, right? Or if your neighbor said that to you, you would know what they're talking about. I just made those up, but hopefully you can extend that example. Right? It's your neighborhood, you know it, you know what's going on. If somebody's in from California and they're lost and they stop they pull up, see you walking down the sidewalk and pull up and like, where do I find this place? You can't tell them it's 2 houses past the Jones's place. They'll be even more lost than they were to begin with. You can't say the house that used to have green shutters because that's not even the color they are anymore. It wouldn't be helpful at all. You would need some sort of way to communicate the location to an outsider. So That's what variables are for. The computer's the insider, and we'll never keep track of that. Start at 84,327 and 8 bits long. We'll forget that as soon as we say it. So we give it a meaningful name. It's like, okay, we're going to call that X. And then the computer's, it's like a house number. All right, the numbers, street numbers. When we have those numbers, it's a standard way to communicate to outsiders how to find a place in our neighborhood. So that's what a variable is. Communication to the outsider. We name a location in memory. So for our intro discussion board, that's what you're going to do. You're going to set up a program that has some variables storing data about yourself. Like me, name is Chris. And if you haven't seen Python syntax, everything about Python is to make it easier for the human. Oh, that's not quite right. I need strings then. Oh, I did that wrong on purpose and already forgot that I did that. So a variable is assigned some value, which at this point, the computer doesn't know what Chris is. We need to make that a string of characters. It's a special type of array, or at least just a special word for an array of characters like we use in our written language. So I'm going to highlight those and hit quotation mark. And most modern text editors, since we need a symbol before and afterwards, with things like quotation marks and parentheses or brackets, if you highlight what goes inside of them, it'll know you want the opening and closing ones to save some keyboard shortcuts.
I had a question. Sorry, are we using Spider to write this?
You can use Spider wherever
Okay.
wherever you want to type is fine.
Okay, thank you. Sorry.
I just wanted to start in the text editor. Is that okay? Yes, any place you have to edit. So I pointed at Spider, that's my preferred one. That's what I'll be using most often. Really, especially starting out here, I wanted to kind of get into the details of trying to look at some of those subtle details about what's happening. So I'm just using a very simple text editor. But wherever you're writing your code, Python code is going to look exactly like this. Or Ripple, the Ripple IT site is a really nice one. It has cloud functionality, so like multiple people can edit at once. There's a chat room, and if you have questions on homework, there's a good chance I'll ask you to hop on that site and we can work on the code together. It's a very, very useful thing. Lots of places we can write code. So I just stored, here's the data I want, but like I put in this diagram to start introducing the stack heap diagram. Oh, I put one more thing on that diagram. So the stack, this side is our code. So this is the code, the text file we write. And then the heap here is what's actually happening in those in the RAM chip. Very few computers these days only have one RAM chip, but I'll say it in the singular fashion. So in this diagram, I'll use to represent things for our code, which has the variable name, and then the actual RAM chip, which has those little electronic switches that are on or off, which we would represent as a 1 or 0 in that nature. So I will draw those pictures a lot this semester to explain things. And then some more data points about yourself. So age, I'll just put 44. And it's I have goldfish. So store some data points and then concatenate together some sort of output to make that data meaningful. I think a lot of you all have had Informatics 109. Had me for that class and remember that important thing. Data is random raw facts that don't mean anything. We need context to turn them into information. So now that we have some data, let's turn that into some information. So I'll make a sentence. I'll just put it right in the print statement here. You can concatenate it together in a sentence, or I'll put it for the beginning here to be fine. We're going to print out some sort of sentence with this. So like the name stored in there plus some more words is the age plus years old and has several plus pets. Plus a period to make that a nice little grammatically correct sentence. I ran out of room. Sidebar. Okay, there we go. I'll fix out the screen there. Is that small? Can y'all read that? Is that too small? I can make it bigger. Settings, let's say 24. There we go, a little bit bigger. Oh, it doesn't fit on the screen now. So I basically put together a string with that data. This one's gonna have an error in it. There's still something to correct. Some of y'all might have already spotted that. But now we can run it. This is a basic text editor, but I still have it set up so that I can access any of my terminals from down here. So we have the PowerShell, or I'm gonna jump into Kali. I'll jump over to one of my other shells. I thought the machine was boot up. There it goes. So from, I don't want to do that. Was that not typing? I'll do this again. So text editors, we can configure this. Any text editor that's not that super basic one, you can tie it, connect it to your terminal and do some stuff there. I'm gonna just go over to the regular terminal. So on Windows, you can push Windows X and open your terminal, or PowerShell, or command prompt, whichever one's there. The new Windows terminal that they just released a couple years ago is a really nice option. Has some really, really great features in there. We'll look at a lot of this stuff over the semester. And now to run that, we need to navigate to the place where that's stored. So I have a little working directory I always use, documents/delete. So I'll change over to the delete folder and list out. So there's that. Now I'm in the same directory as that. So to run that script, this is what happens if you push the green button, if you were type that is spider instead of the text editor like I did. To run that, we need the instruction Python that starts the Python interpreter, and we want to start it with that file, intro.py. And there's an error in there, so there's gonna throw a message. In class, I like to throw error messages. In tutorials and textbooks, you always see that nice finished product where there's no errors, and when we start writing code, we see errors left and right. And the tutorials that are all polished and practiced ahead of time, but very restricted on time, so they just skip the error messages. That's perfectly normal. And in class, I like to throw error messages on how to fix them. So we kind of read these backwards. So the problem is at the bottom. The type error can calculate strings and integers. So there are different data types. We can't put integers and words together. Numbers and words are different things. One's for doing math, one's for writing sentences. It says where it's at, the line, and on line 8. So we can come back over to our file, find line 8, and we'll have to track it down. So name, that's a string. We're allowed to concatenate strings, so can be that one. Age looks like a number. So need to change age into a string. So you'll probably need this one a lot for your intro discussion board if you haven't seen it. Our keyword to turn a number or Boolean or turn something into a string is the abbreviation for string, str, and then all of this gets wrapped in parentheses. Then the number gets passed in as an argument. That's our term for that. Arguments get passed into methods, and this particular method turns that into a string. And then the other one looks like it was also a string, it was also a string data already. Python is open typed. We don't have to say what type of data we have, but we do have to stick with that type of data. Because like we just saw there, once the Python interpreter figures out what our data is, like once it determined that age variable is a number, we couldn't treat that as the symbols for 4. It has to be the number 44. So we don't have to say what type of data we have, but we do have to stick with that type because it'll just confuse the interpreter if we don't. So now that that's there, I can come back over to the terminal, clear all this stuff out of here and run that instruction again. We can pretty much any terminal, we can just use the up arrow to get back to previous ones. That's very, very common when debugging a program. Push up, run that previous instruction, and there's that sentence that came out. So basically, that's what your introduction discussion board is going to be and look like. It doesn't have to be big fancy sentences. Why don't I go ahead and turn that into 2 sentences? So Chris is 44 years old, period. And let's see, then I'll add the parenthesis there. And then I'll put the keyword print and add a parenthesis there. Anybody that's seen Python before, is that going to run?
I didn't get that.
So I took what was there and split it up into 2 sentences. So now Chris is so many years old, and then it'll print another sentence. It's like Chris, I guess I don't need to add. Chris has several pet goldfish in this case. Is there a problem? Anybody that knows Python, done Python before? We can always check, right? That's why, that's the debugging process. We go run our code to see if it works. I'll try to run it. Oh, got another error message. Yeah, I guess you were typing that whenever I hit run. White space matters in Python. Curly braces and semicolons. Semicolon means end of instruction. We'll see some C family stuff later. So like every time we type a line of code, we have to actually explicitly say end of instruction at the end of every line. People were thinking that can be a little difficult, and if we miss one, semicolon's a little hard, a little bitty symbol that might be hard to see if we're staring at screens for hours. So when they did Python to make it easier for humans, they went with what we naturally do. The instruction ends with a line break instead of a special character. And we indent to put things together. So curly braces define blocks of code in our C family languages. There's like, okay, a small block of code from an opening curly brace to an ending curly brace goes together. And when they were trying to make everything easier for humans in Python, they thought, well, humans do indenting to do that, kind of like a bulleted list. At the first indent level, all goes together. Next indent level, all goes together. So white space matters, which is generally easier, but looking for a missing curly brace has nothing compared to looking for missing white space. It can be really, really hard to find the wrong white space in your file. So indentation errors are one you'll probably see a lot. A couple of useful keys, if you haven't seen them yet, I'm gonna talk about keys. I'll mention these again. Home and in. Make sure you know where home and in are in your keyboard, because oftentimes we need to get to those spots. And if we hit in, now, before the days of a mouse, we use the shift key to select. So if you hold down shift and move the arrows, you can see the highlighting happen. It often happens in programming, we need to highlight a whole line. So a really easy thing to do is like push the in key and then hold shift and push home. Whoops. Let me try that again. In, and then when you hold shift and push home, I accidentally bumped the page up that first time. It highlights that whole line. And I always do in first, because if you push home again, Notice that highlighting is toggling back and forth between the end. So with Python, I push home, get my cursor there at the beginning. If you have an indentation error, it is usually best to let the editor handle that for you. The official thing is it should be 4 spaces. It looks like my text editor is doing the tab. We can use either one. The thing is we cannot mix them. The people who wrote Python said 4 spaces. So that's what you usually want to go with. But if some things are tabs and some things are spaces, so like if you use more than one editor with the same file and copy and paste, open it someplace different, or update your stuff and then open a file that you worked on previously, those don't work together. We have to stick with one or the other. And it's best to let the editor fix it. So what I always like to do is go push the home key and hit backspace till I'm on the previous line, and then when I hit enter, any decent editor should get the indentation. Because when we do it manually, it's something we often get wrong. So let that computer edit that. We'll talk about keyboard shortcuts. Make sure you know where things like the home and end key. Those are incredibly useful ones to find, and they're on a different spot on every keyboard. We'll see stuff like that. Now this should run. I go back over here, push up and run that again. There we go. And that's what your intro discussion board is. I put a number on there, which was just off the top of my head when I was writing those instructions. And then you need so many variables and so many sentences. So, and it's not a 1-to-1 ratio, so things get reused. And remember, you're not writing a paragraph about yourself. You're not saying I and me, you're writing a program that introduces you. So it's not really third person. You're an outsider to the program. So go ahead and use your name over and over again. And whatever those instructions were, that's what that first discussion board is. And when you get it up there, you'll take a screenshot, Windows Shift S, if you're on a Windows key, Command Shift 4, or Command Shift 3, or Command Shift 4 on a Mac. You'll take a picture of the output and the code, all that stuff. And the thing I ask is that whenever you make your post on the discussion board, make sure they can see it. Use the insert button and insert an image, which I don't think I saved that image. I just took. I didn't save that image, so it's just a random image I have on the computer. So make sure I'm going to delete this in a second. So make sure you insert that in such a way that your classmates can see it without downloading. So don't just attach the picture separately. Like don't do a link to the picture. Make sure that use the insert button and make sure they'll be able to see it without downloading any files. Then once the picture's in there, but that was just a random picture because I forgot to save that one. I took of the actual output. There's an example from a couple semesters ago. Must have been 2 years ago. It says I was 42 in the picture there. So must have been 2 years ago, at least. Yeah. Does anybody have any questions about that assignment?
Yeah, I got the error message.
Okay, we'll look at it here in just a second. You don't have any general questions, right? See what to do, just fix an error. Okay, so I will, we'll look at that here in just a second. So tonight went a little long. We still have about 45 minutes left on our scheduled block of time. I'm gonna do stuff. This is an active subject we learn by doing. So the best thing to do is do stuff and learn. That discussion board is a good one to get knocked out quick. There's other assignments. Whatever y'all feel like doing, it's your time. Until our scheduled block of time ends at 8:50, I will be sitting here just ready to ask questions. Please use our time productively. You should have this marked off on your schedule as time to learn software development. Otherwise, I will see y'all on Wednesday and we'll get into more serious examples. Tonight's examples were really just filling space after we read the syllabus. Oh, before we wrap up, does anybody have any questions? Other than like individual questions like error messages that we can address after the Zoom callings. Okay, I assume 5 seconds of silence means no questions. Y'all have a great evening. If you have any, send them my way. Otherwise, I will see y'all on Wednesday.
Thank you.